the last lecture, we discussed about the basic concepts in current electricity. We discussed about the Kirchhoff's first law or current law. Now, we were discussing at the end of last lecture about Kirchhoff's second law or Kirchhoff's voltage law. I had explained the mathematical statement and convention how it is to be used was remaining. So I am doing that with the help of this diagram, and then I will solve one numerical from the textbook exercise in order to understand how these conventions are to be used. Someone might argue that why numericals are being taken along with this, but in order to understand the conventions used in Kirchhoff's current and voltage law, you need to solve numericals. Many times such type of numerical comes for 3 marks, so we are going to deal with that. Now, we had discussed Kirchhoff's voltage law is in accordance with conservation of energy. Mathematical statement I explained, I was on here explaining the convention. If you are considering the loop in the direction of conventional current, that is from positive terminal to the negative terminal. For example, I am writing the loop here. In loop, observe how I am considering. Last time I told you, generally when I solve these type of numericals or questions, I start from the positive terminal of the battery. So I am starting from E1, that is first cell, going to point A, then going to point B, coming down to point E, moving to point F, and coming back to E1. Just check whether this is a closed path for the flow of current. It is a closed path for the flow of current. What is the direction of the current? It is going to be from positive terminal of the battery to the negative. So this particular arrow is showing the direction in which current will flow. So what is said here? If the direction of current and the direction of loop are same, current is taken as negative. From where I am starting? I am starting from the positive terminal of the battery. Now apply this. I am applying this law. In this particular loop, there is only one cell, although there is a second cell on the other side which we are not concerned about. So, in this particular loop, how I am going to start? Start from the positive terminal of the battery. Therefore, instead of summation E, I will write E1. Check. Everyone try to follow this. I am starting from the positive terminal. Therefore, I am considering E1 as sum of all the EMFs. There is no second cell. In this loop, here on this side there might be other cell, but I am not concerned about that. Now what is the current flowing through R1? Come to this second part. I am writing plus. Now what are the currents and the resistances in the path? See, I1 flowing through R1. But what is the direction of the loop and direction of the current? They are same. So I will write minus I1 into R1. Have you followed? Just check. Direction of current and direction of loop are the same. Therefore, the current has to be taken as negative. And what this term is saying, find the product of current and resistance in all the loop and add them. So this is going to be the second part. This I am talking about. This is referring to this. The current I1 comes here. Current I2 comes from this side. Both the currents together through the resistance R2. What is the direction of the current that we are assuming? In the direction of the loop. So, plus minus I1 minus I2 into R2. This part, this region. Once again, I1 comes from here, I2 comes from here. Apply Kirchhoff's first law here. Current approaching the node from this side is I1. Current approaching the node from this side is I2. Therefore, current leaving the node must be equal to sum of the currents entering. So, the current through this path is I1 plus I2. But it is in the direction of the loop. Therefore, I have taken both the currents as negative. At this junction, what is the current coming in? I1 plus I2. Out of that, I1 will return to the first cell. I2 will return to the second cell. So I1 is the current flowing through R5. Equal to 0. Now, how this equation can be modified? Just check. Just put all the negative terms on the right hand side so that they become positive. So I will keep E1 on the left hand side. E1 equal to, this is I1 R1 plus I1 plus I2 into R2 plus I1 R5. I've got one equation in I1 and I2. What type of questions do they normally ask? What is the current flowing through the external resistance, that is this resistance? So if I find I1 values of I1 and I2, then I can just add them up or solve two equations simultaneously. Now I am writing the equation directly for this loop. E2 equal to, check, I am not using that first method now. It will be too descriptive, too time consuming. Apply the same logic. Now which is the loop? E2 C B E D back to E2. Starting from positive terminal, E2 will be positive. Current I2 flows through I3, R3 plus I1 plus I2 flows through R2 plus I2 flows through R4. Check. You will be given the values of E1 and E2. You will be given the values of external resistances. What you don't know are the values of I1 and I2. A typical sum in which they might ask you to find the current flowing through all the resistances. Means you will have to find I1, you will have to find I2, and you will have to find I1 plus I2. So these are two simultaneous equations which can be easily solved. I suppose that all of you are well acquainted with simultaneous equations in two variables. So we can solve them and get the values of the current. These are called as Kirchhoff's current and voltage law, or Kirchhoff's laws of current electricity. When you are writing the answers in the answer paper, read the question carefully, because there is one more Kirchhoff's law in physics 1 that is related to heat and radiation. So read it carefully which Kirchhoff's law is asked. Now I am taking one numerical from exercise. I am going to give you one numerical as homework also, because it will consume a lot of time being the first numerical. Page number 229. Refer to this page. Answer in brief. The 10th sum I am solving. 11th sum is for you to do as homework. So 10th sum, what does it say? It is given in statement form. Pay attention. You will be given the numerical in statement form. You will have to construct the network or the circuit. Because unless you do that, you will not be able to identify the loops and solve them. Whatever I am doing, follow exactly the same procedure except for solving the simultaneous equation for question number 11, that is going to be as homework, going to be given as homework. A battery of EMF 4 volt and internal resistance 1 ohm. Is connected in parallel with another battery of EMF 1 volt and internal resistance 1 ohm. See, E is representing EMF, small r is representing internal resistance. As discussed earlier, every cell will have some internal resistance. These values are given. Further, they say, with their like poles connected together means positive of first is connected to positive of second, negative to negative of second. The combination is used to send a current through an external resistance of 2 ohm. Whatever combination you have, that is used to send a current through an external resistance of 2 ohm. Calculate the current through the external resistance. As I told you earlier, what you want to find out is this current. Now, generally, label at every junction so that you can identify the loops. This gives you the diagram now. It is diagrammatic representation of what question is asked. Let us assume this cell is sending current I1. So I1 comes from here. Fine. This cell is sending current I2. At this point, observe the total current coming in. It is I1 plus I2. If the cell is connected in the opposite direction, it is going to be I1 minus I2 or I2 minus I1. That time we have to consider the EMFs and the internal resistances of the cell. We'll solve some of that type also later on. Now, this current is passing through this. At this junction, it comes as I1 plus I2. I2 will go to this battery. I1 will continue to flow up and return back to the negative terminal of first cell. So now the diagram is complete. I will formulate two simultaneous equations. Very easy. Again, now you can understand how this is to be applied. Which loop I am considering? Generally consider the loop which consists of one cell only. So I am considering the loop in loop, observe which I am selecting in loop, starting from E1, moving to point A, moving to point B, moving to point C, moving to point D, moving to E, F, back to E1. Check out whether you are following it. I have considered this loop. Now, there is no resistance in this part. In this loop, I have started from the positive terminal of the battery, so I will write E1 equal to, or if you want me to use the convention once, I will do that. Current is flowing in the same direction as that of tracing the loop. So, this current is negative, minus I1 plus I2 into R. This is the resistance. Come back to the negative terminal along the loop. So, this part I am not considering. Here, I1 is the current flowing through R1, but direction again same as direction of the loop. So take this I as I1 as negative. Now whatever values you know, substitute them. What I know, value of E1 is 4 minus I1, I2, I don't know. Value of R is 2 minus value of R1 is 1 equal to 0. Just simplify this. This is very simple. 4 equal to what you are getting. Shift this on the other side. So 2I1 plus I1, 3I1 plus 2I2. This is my equation number 1. Consider second loop. You need at least 2 equations to solve where there are 2 variables. I1 and I2 are 2 variables. So you will have to have minimum 2 equations. For that matter, now I am considering the loop. Think yourself in loop. I told you earlier, don't consider the loop as far as possible containing 2 or more cells. I am considering this as one loop. So this battery is involved and this as one loop. So this battery is involved. Now think by yourself. I am writing the loop directly. E2, B, C, D, E, E. This is the loop under consideration. Formulate a similar equation. E2 minus. Why minus? Direction of the current and direction of the loop are same. I1 plus I2 into 2. This current enters here, I2, again minus I2 into 1. I have not written the intermediate step like this now. Here what you will have to write? You will have to write R here and R2, small R2 there. So now you can substitute the values here and shift all on that side. So now they have given 1 volt or 1 equal to, this is 2 into R1 plus I2 plus I2. Simplify this. What you are going to get? 1 equal to 2I1 plus 3I2. This is your equation number 2. How you are going to solve these equations? Very simple. What you want to find out, the current through the external resistance means I1 plus I2. One way is to solve these separately get values of I1 and I2 and then write I1 plus I2 equal to I. But there is a easier method for such type of equations. Equation 1 plus equation 2. Just check what you are getting. 4 plus 1, 5 equal to. Here 3I1 plus 2I1, 5I1. 2I2 plus 3I2, 5I2. Therefore, 5 equal to 5 into bracket I1 plus I2 or I1 plus I2 equal to 1 ampere. This is the way these equations are to be solved. 11th sum I am giving you as homework. Now I will give you a brief introduction of a new part which will be coming across. That is called as Wheatstone's network. It is very important because in practicals also you will be using Wheatstone's network, Wheatstone's meter bridge, etc. So let us understand what is Wheatstone's network first. It consists of 4 resistances as 4 sides of a quadrilateral. They are labeled as R1, R2, R3, R4. I am labeling these points as A, B, D, and C. Between any two opposite points of the opposite vertices of the quadrilateral, a galvanometer is connected. What does the galvanometer do? Galvanometer shows whether there is current present in the given circuit or not. It will just show the reflection if current is present. Remaining two vertices are connected to a battery, key, and rheostat or resistance box in order to adjust the current. It should not happen that large current passes through the galvanometer, deflection goes out of scale, and suddenly the galvanometer coil is damaged. In order to control the current flowing through the galvanometer, this variable resistance is generally provided. A key is connected so that you can disconnect the circuit, and a battery of certain EMF is connected. This is what is called as Wheatstone's network. This is to be used for Wheatstone's meter bridge for different purposes in the laboratory within the scope of 12th standard syllabus in practicals. So understand this particular network first. Then what is the balancing condition? That question might come in the mind. Now balance means what? Balance means there is no current flowing through the galvanometer. When you will say galvanometer is balanced, when there is no current flowing, so that the pointer remains on 0. Must have seen a galvanometer. When this pointer remains on 0, the circuit is said to be balanced. That is what is called as balancing condition. Balancing condition I will tell you in advance. The balancing condition is, how to derive it, we'll see. R1 upon R2 equal to R3 upon R4. You have to derive this mathematically using Kirchhoff's laws. So that we'll be doing maybe in the next lecture. Before that, I'll just show you current I flowing here at this node. Some part of the current goes here I1, some part of the current goes here I2. Here, whatever current is flowing through the galvanometer, I am assuming it to be zero because we want to find balancing condition. So whatever current I1 comes here, it has to go further, it cannot get accumulated here. I2 has to go here. Then apply Kirchhoff's voltage law for two different loops, any of them, and you can automatically get to that balancing condition. In the next lecture, we will finish it off and then go to Wheatstone's meter bridge and its applications. Thank you.